9 for multiplying special cases. All right, so we have two objectives with this section. Find the square of a binomial. This is something you are going to love and want to know. This will make your life so much easier down the road. And then find the difference of squares. This one is easy. So easy, I didn't even spell easy correctly. All right, let's go ahead and go to example 1. The square of a binomial. Now, I have really done my students a disservice in the past few years, or the past maybe even 8 years, because I did not require them to memorize this. You want to memorize this. It will make your life so much easier when you get to Algebra 2, all right? For those of you who aren't planning on going to Algebra 2, you still want to know it because you will need to do it when you get to college. So either way, just commit it to memory, right? So if we have a plus b, we have a single binomial squared. It's the first term squared, the last term squared, and then we multiply the two terms together and double them. So if it's positive, it will be positive. If it's negative, it's going to be negative. It's wonderful. This thing is so wonderful. Now, worst case scenario, you forget how to do that, you can always FOIL. But I'm telling you, you want to learn how to do this particular method using this property. All right, so we have find y plus 11 squared. So that's y plus 11 squared. This is my a, this is my b. And remember, I'm going to rewrite this up here. A plus b squared is equal to the first term squared, the last term squared, and then we multiply these two together and multiply it by 2, so 2ab. Okay, so that's going to be y squared, and then 11 squared, and then I'm going to multiply these two together, and that's 11y, and then we have to double it. Now it's positive, so this is also positive. So now that gives us y squared plus 22y plus 121, and that's it. Okay? In fact, I'm not even going to show you how to do it using the FOIL method, but I will tell you that if this is squared, then you know y plus 11 squared is equal to y plus 11 times y plus 11. Knowing this property makes it so much faster for you. So like I said, I'm going to say it again, memorize it, learn it, love it, embrace it. All right, this is our A, this is our B, and you'll notice this one is a subtraction. So that's going to be 3w squared, the first term squared, the last term squared, and it doesn't matter if it's positive or negative because when we square it, it becomes positive. Multiply these two together, 3w times 6, and then since that's minus, we'd have minus 2. All right, so 3w squared, 3 squared is 9, w squared is w squared, 2 times 3 is 6, 6 times 6 is 36, so we would have negative 36w, 6 squared is 36, and you are done. All right, let's do one more, and then we'll go on to the next example. We've got a bunch of examples to get through, so I don't want to get stuck on this one. Let's do C because it looks like it may be the most complicated because we have two different variables in here. So we've got 7m minus 2p squared. So we know we're going to be doing the a squared minus 2ab plus b squared, where 7m is the a, 2p is the b. So that's 7m squared minus 2 times 7m times 2p, and then plus 2p squared. All right, so 7 squared is 49. Then we have that m squared. 2 times 7 is 14. 14 times 2 is 28, and there's negative, so it would be minus 28, and then we have m times p. And then 2 squared is 4, p squared is just p squared. This would be your answer. Okay? Any questions, please see me. We're going to go ahead and go on to example 2. This one is one of the Punnett squares, and this is something that you'll be looking at in your science class, I believe, but I'm not 100% sure where you guys get this. But this is one real world application of it. So let's go ahead and scroll down to see our example. Among guinea pigs, the black fur gene is dominant and the white fur gene is recessive. This means that a guinea pig with at least one dominant gene, BB or BW, will have black fur. A guinea pig with 2 recessive genes, WW, will have white fur. What are we supposed to do? But it doesn't say find the probability. Yeehaw. All right, so I guess we are supposed to find the probability. Jeez, I don't even know. I have no idea. I'll have to come back to this one, add it to it, okay? Let's go ahead and skip this one for right now. The difference of squares. Oh my goodness. This one is so awesome. You are going to love it. Love, love, love it. Swear. All right. A plus B times A minus B. So same terms, but opposite signs. It's just the first term squared minus the last term squared. Oh my goodness. That's it. That's it. That's it. So looking down here, t cubed minus 6, t cubed plus 6. Same terms, different signs. So it's t cubed squared and 6 squared. T to the 6th minus 36. Yeehaw, you're done. So p to the 4th minus 8 times p to the 4th plus 8. So these are the same, these are the same, but these are different. So that's a difference of squares. So this is going to be p to the 4th squared minus 8 squared. You take your first term, square it, the last term, and you square it. P 4th squared, remember when you have a power to a power, you multiply. So this would be p to the 8th minus 8 squared is 64. That's it. That is all you have to do. So awesome. All right, let's do one more before we go on to the next example. Let's do C. C tends to be the one that everybody likes to jump on because they think it's going to be hard, but it's really not. It does recall using the stuff we learned in chapter 8 with the exponents, but you know, that's just a necessary evil. Okay, so this and this are equal. W4 and W4 are equal, and then we have different signs, so difference of squares. So this is 9b cubed squared minus W4th squared. Now, we have two terms here, so this would be 9 squared and b cubed squared. So this is going to be 81 b to the 6th, and this is 4 W4th squared, so power to a power means you multiply. And that is your answer. Now make sure when you have two terms, or two factors within a term, sorry, I always say that improperly, that you are raising both of those factors to the power. You can't just do the b, you have to do the 9 as well. All right, I think there's one more example. And we are skipping this. We are not doing this one. I know. That one will end up messing you up like nobody's business. So I'm not even having you do those, all right? Just focus on Who knows what example 2 is supposed to be. Focus on the squaring, the binomial, and the difference of squares, and you will be just ridiculously successful. But you're going to have to practice it. You can't just do one or two and then be like, I'm done. You have to practice it. Okay? More practice, the better you get.